Hello, and welcome to this segment of Preparing for Success on the ACT Math Exam with Roger Melton. Be sure to download and print the accompanying handout for this podcast. Enjoy.
This podcast is entitled Systems of Equations. Most systems on the ACT test are two equations and two unknowns. Knowing that these systems have three types of graphs will be helpful when taking the test. One type has two intersecting lines and a unique value for each unknown. The point of intersection has coordinates a comma b, so the solution becomes x equal a, y equal b. A second type has parallel lines, no points of intersection, and no solution. A third type of system produces a single line as the graph of both equations, producing infinitely many solutions. If a system of two linear equations and two variables has no solution, and one of the equations is graphed in the xy coordinate plane below, which of the following could be the equation of the other line? In order for the system to have no solution, the graphs must be parallel lines. Thus, the other line must have a positive slope and a y-intercept not equal to 3. Choice G, y equal 2x plus 2. How many ordered pairs xy of real numbers will satisfy the equation 2x minus 5y equals 6? A single equation in two unknowns has infinitely many solutions. To see 5 such solutions to 2x minus 5y equals 6, complete the following table of corresponding pairs. Choice K, infinitely many. What is the value of b in the solution to the system of equations below? The system is 3a minus 2b equals 21. A plus 3b equals negative 4. By Kramer's rule, b equals the quotient of two determinants. The top determinant has in the first column the coefficients of a, and in the second column the constants from the right-hand side of the system. The lower determinant has the first column as coefficients of a, and the second column coefficients of b. To evaluate the determinant, you'd crisscross the product of 3 and a negative 4 minus the product of 21 and 1. That becomes negative 33. Same is true of the denominator. 3 times 3 becomes 9, and you subtract the product of a negative 2 and 1. And that becomes 11, and the quotient becomes negative 3. Choice D. For what value of a would the following system of equations have an infinite number of solutions? The system is 2x minus y equals 6, 8x minus 4y equals 3a. The two equations must be equivalent. The bottom equation appears to be the top equation whose sides have been multiplied by 4. Thus, the top equation, constant 6, multiplied by 4 equals 3a. So 24 equals 3a, or a equals 8. Choice H. In this problem, two equations are given, and you're asked to find the value of x plus y. First equation is x plus 2y equals 1. The second equation is 2x plus y equals 5. Rewrite the given equations. Add the sides together. They've been written in a vertical form, and by adding the x coefficients, you have 3x, and the y terms become 3y, and the constants become 6. Dividing both sides by the common factor 3 yields x plus y equal to 2. Choice G.
Thanks for listening. We hope you found this podcast segment helpful in preparing you for the ACT. Please continue to the next podcast.